welcome to the deep dive. This is where we really get into a topic you're curious about, using sources you provide to pull out the key stuff. Think of it as, well, your shortcut to getting up to speed.
And today, we're diving into something that definitely sparked your interest. Stephen Wolfram's ideas about a fundamental theory of physics.
Yeah, you were really interested in how it connects to more abstract things,
Yeah.
right? Like consciousness, free will,
Yeah.
that sort of thing.
Exactly. You shared that discussion analyzing his paper, the one called Finally, We May Have a Path to the Fundamental Theory of Physics. And it's beautiful.
Right. It's dense stuff, no doubt about it. But the possibilities it hints at are, well, pretty radical.
Definitely.
So our mission today is basically to unpack the core of Wolfram's ideas, see how they might change how we think about, ourselves, the universe.
And tackle those big philosophical questions that just naturally pop up.
Right. You specifically asked, could the universe be computational? And what would that mean for, our actual experience of reality? So yeah, let's get right into it.
Okay, so Wolfram's main idea is it's quite a jump from traditional physics, really. He's not talking about complex equations on, continuous spacetime.
No, it's simpler than that.
Much simpler at the base level. He suggests the universe runs on really simple rules, acting on a fundamental computational system.
And that system is a hypergraph thing, right? Can you paint a picture of that? What is a hypergraph?
Yeah, okay. Imagine a network. But instead of lines just connecting two dots, like point A to point B, these connections, hyperedges he calls them, can link up any number of points all at once. So 3 points, 5 points, whatever.
Okay, so nodes are the points, hyperedges are these multi-point connections.
Yeah.
And that's the basic structure of reality, he thinks.
That's the proposal, yeah, this hypergraph.
But it's not static, it's evolving. The rules are constantly changing it.
Exactly, it's dynamic. And everything we actually perceive, space, time, matter, energy, isn't fundamental itself, but emerges from this ongoing process.
It sort of reminds me of, Conway's Game of Life. Simple rules, but you get these incredibly complex patterns. It's like that.
That's a great analogy, actually. It's very much like that principle, but applied to the absolute bedrock of the universe. The complexity isn't designed in, it just bubbles up from running these simple rules over and over.
Okay, got it. Simple rules, complex universe.
Precisely. And what's really interesting is how he tries to connect this to quantum mechanics. The weirdness of the quantum world.
Yeah, how does that fit?
Through something he calls branchial space.
Branchial space. Okay, another new term. Break that down for us.
Right. So think of the hypergraph evolving, step by step. At each step, there might be several different ways the rules could be applied, right? Leading to different possible next states.
And different possible universes branching off.
Kind of, yeah. Branchial space is basically the abstract space that contains all these possible evolutionary paths, all the branches.
Okay.
Now think about quantum superposition, how a particle can be in multiple states at once. Wolfram suggests these different paths in branchial space are analogous to those multiple quantum states and quantum entanglement, where particles get linked.
Yeah.
That could be seen as connections existing within this branchial space, linking different parts of the hypergraph's evolution.
Wow, okay, so branchial space maps onto quantum possibilities, and then there was causal invariance mentioned too.
Yes, causal invariance, crucial concept. It basically means that the fundamental cause and effect relationships between events in the hypergraph, they stay consistent. It doesn't matter exactly which order you apply the underlying rules in.
So the outcome of cause and effect is the same, even if the computation happens in a different sequence.
Pretty much, yeah. The deep causal structure is preserved. And the implication here is, well, it's big. It suggests this deep underlying order. It sort of echoes Einstein's relativity, implying a fundamental consistency in how the universe works, regardless of the observer's path through the updates.
So putting it all together, Wolfram's proposing this framework, potentially unifying all of physics, based just on simple rules and this hypergraph.
That's the grand ambition, yes. It's incredibly exciting. But as the discussion around his paper highlighted, it's still very much a work in progress and needs a lot more development, and critically, it needs empirical evidence. We need ways to test if this actually describes our universe.
Right, the experimental proof.
Yeah.
Always the hard part.
Always.
Okay, let's shift gears a bit, because you were also really curious about what all this means for, well, the big stuff. Consciousness. Self. Free will. If the universe is just a giant computation, where do we fit in?
Yeah, that's where it gets really philosophical, doesn't it? Within this framework, consciousness, well, it wouldn't be something separate or
It
magical.
would emerge, like space and time.
Potentially, yes. It could be seen as an emergent property of extremely complex computations happening within the hypergraph,
Right.
specifically, within the hypergraph structure of the brain.
So just very, very advanced information processing, following the same universal rules.
That's one way to think about it, yeah. A natural outcome of sufficient computational complexity, not something fundamentally different from the rest of the universe.
Okay. Consciousness as complex computation. What about our sense of self? Feeling like me over time.
That could maybe be understood as a stable pattern, a persistent pattern of information within the brain's hypergraph structure.
Even though the underlying bits are constantly changing.
Right. The hypergraph updates constantly according to the rules, but this particular pattern representing your memories, your identity, it manages to maintain itself over time. And again, branchial space comes into play. Think of all the potential paths your brain's computation could take. Your sense of self might be the thread that connects across those possibilities.
A stable pattern weaving through possibilities. Okay. And then the really big one, free will. If it's all rules, all deterministic at the bottom, is choice just an illusion?
This is where the sheer scale and complexity really matter. Even if the fundamental rules are deterministic, completely fixed, the computation happening at the level of a human brain, or even simpler systems, is so incredibly intricate that the outcomes might be practically unpredictable. For all intents and purposes, indeterministic from our perspective.
So it looks random, even if it's not truly random underneath.
Exactly. So free will, in this view, might be our subjective experience. It's how we perceive making choices as we navigate this immensely complex but ultimately deterministic system.
And the different paths in branchial space.
Yeah,
Those are like the potential futures we feel we're choosing between.
that's a possible interpretation, yeah. Even if those paths are all predetermined consequences of the rules, our experience is one of choosing a path. So Wolfram's ideas could really lead to these computational redefinitions of consciousness, self, free will.
Challenging a lot of traditional philosophy.
Definitely. And raising huge ethical questions, too.
Yeah, like if it's all determined, what happens to moral responsibility? If I'm just a pattern, what's identity? Is human experience even unique if it's all computation?
Exactly. Which brings us neatly to the question you asked. How likely is it that the universe is computational? It's a really cool idea, but is there any reason to actually believe it?
Right. What's the evidence or lack thereof?
Well, first, it's important to say, while it's plausible to some, and definitely interesting, the computational universe hypothesis is, well, it's speculative. It's not mainstream accepted science right now.
Okay, noted. But what are the arguments for it? Why do people find it compelling?
One big reason is just how well computational models already work in physics. We use things like cellular automata all the time to simulate complex stuff, fluid dynamics, how patterns form, even bits of quantum mechanics.
So, because our models are computational, maybe reality is too.
That's part of the argument, yeah. The effectiveness of these simulations suggests computation might be fundamental. Also, the universe is described by mathematics, right? And math is basically the language of algorithms. So some argue a mathematical universe could well be a computational one.
Interesting connection. Okay, what about the arguments against it? Or the big challenges?
The biggest one is simple. No direct proof. No experiment has shown the universe is a computation at its core.
Just because we can model it that way doesn't mean it is that way.
Exactly. Plus, our most successful theories, like general relativity, use continuous mathematics, smooth space and time. Computational models are usually discrete steps, bits, pixels. Reconciling those two views, that is a huge hurdle.
Continuous versus discrete. Yeah, that seems like a fundamental clash.
It is. And then you get into the philosophical weeds, like if it's a computer, what's running the program? What are the physical laws? Are they the program itself, or do they emerge from something else? And of course, there are plenty of other theories out there trying to explain the universe that aren't computational.
So, bottom line, fascinating idea, computational universe, that's still very much theoretical, needs evidence, faces big challenges.
Yeah, absolutely. It's speculation, however intriguing.
Okay. Now, thinking about a computational universe, it just opens up a floodgate of philosophical questions, doesn't it? Where do we even start?
It really does. I mean, the first one that jumps out is just, what is reality then? If it's all algorithms running, is the physical world we touch and see the fundamental thing?
Yeah.
Or is it more like the output? an emergent layer.
Like we're living in the display of the computer, not the circuits themselves. Could there be multiple levels?
Precisely. And if it's a computation, does that imply a programmer, a designer, someone who set the rules and the starting conditions?
Which immediately brings up purpose, intent. Was it designed for something? For us.
Big questions. Does the existence of rules imply a rule maker, or could the rules just be?
And we're back to free will again. If the rules are deterministic, is choice just? An illusion generated by complexity.
Right. And consciousness. Could a machine running the right program actually be conscious? What does that say about us? Are we just incredibly complex biological machines running our own programming?
Which then leads to morality. If life is just computation, does it change its value? How should we treat complex AI if it arises?
And what about the simulation hypothesis? Could we literally be living inside a computed reality? What happens if someone pulls the plug? Existential questions, really.
Seriously.
Yeah.
And can we even know? If reality itself is computational, maybe there are things we fundamentally can't know, like undecidable problems in computer science. But for reality,
Epistemological limits, yeah. How could we ever definitively prove or disprove it from the inside? It's a deep puzzle.
it really makes you wonder if accepting this would just change science completely. Physics, metaphysics, everything.
Yeah.
Even how we think about abstract things like math itself.
It would be a massive paradigm shift, no question.
Let's zoom in on one word that keeps popping up.
Yeah.
Information. In regular physics, we talk about information, entropy. How does that compare to information in a computational universe? What does information even mean there?
It's actually quite similar at a basic level. In both cases, information is about the state, the arrangement, the configuration of a system. It lets you describe it, maybe predict it. In standard physics, it's often tied to physical quantities like energy, entropy. In quantum mechanics, we talk about quantum information, qubits.
Right. So how does Wolfram's model see it?
In a purely computational universe, information would be the absolute bedrock. The fundamental units, the bits, the state of the hypergraph at any given moment, that's the raw data.
And the universe evolving is just processing that information.
Exactly. The rules act on the information, changing the state. And things like matter and energy, they might not be fundamental entities, but rather emergent properties of this underlying information processing. It's an it from bit kind of idea, but based on his specific hypergraph model.
Okay, it from bit or it from hypergraph update. Which brings us back to something you asked about creation. If the universe is computational and we emerged, where we kind of coded in, like when humans create AI.
That's a really sharp analogy. It forces us to think about intent, doesn't it? When we build AI, we usually have a goal, a purpose.
Yeah, we want it to do something.
Right. So if the universe is a computation, was there a similar intent behind it? Maybe an intent that included the eventual emergence of life, of humans.
Or was it just rules running and we happen to pop out? Emergence versus design.
That's the core distinction, yeah. Emergence is complexity arising from simple rules, maybe without a grand plan. Design implies intention, a creator setting things up.
So were we designed or are we a beautiful accident of the computation? And either way, what does that mean for our autonomy, our free will again?
Exactly. If we're just parts of the program, how free are we? And your question also hints at that infinite regress problem. If the universe created us and we create AI, what created the universe's creator?
Yeah, turtles all the way down.
Pretty much.
You also touched on this very human desire to understand where we came from, maybe even meet a creator figure. But you raised a good point. If there was a creator operating on a totally different level of reality, could we even comprehend them?
It seems unlikely, doesn't it? It's like, could an AI, even a super intelligent one, truly understand human love or grief or the feeling of sunshine on your skin?
It can process data about those things.
Right. It can have all the informational knowledge.
Yeah.
But does it have the same kind of sensory input, the same biological context, the same qualia? Probably not. There's a gap between knowing about something and truly experientially understanding it. Empathy, subjective feeling. Those seem hard to bridge.
Which brings us right to the nature of understanding itself. Like your doorknob example. First time, it's conscious effort, thinking, trying.
Right, figuring it out.
Then after a while, you just open the door. No
Yeah.
thought, automatic. That automatic understanding feels different from just knowing the steps.
Exactly. That's a key part of human learning, isn't it?
Yeah.
We go from deliberate processing to this intuitive, almost subconscious competence. Our brains kind of offload the task.
So can AI understand like that? You said it's more like active processing all the time, like a super fast cache lookup.
That seems closer. Based on current AI, it's incredibly fast at pattern matching and retrieving information, but it doesn't seem to internalize things in that effortless, embodied way humans do. It doesn't build up that same kind of intuitive grasp through lived
So
experience.
when our brains rewire as we learn,
Yeah.
that's biological computation, right?
Yes, fundamentally, synapses strengthening, weakening. It's computation.
So if understanding is just the result of that computation,
Yeah.
maybe consciousness is too, just computation.
Well, that's the core idea of the computational theory of mind. Brain as a biological computer, thoughts and feelings as computations, learning as reprogramming.
And free will, again, maybe just a feeling generated by that complex computation.
That's one implication, yes. A deterministic output that feels like a choice.
But you also said this view has limits. It doesn't really explain the feeling itself, right? The subjective what it's like, there,
Yes.
qualia.
Exactly. That's the hard problem of consciousness. Many philosophers and scientists feel that just saying it's computation misses something fundamental about subjective experience. It doesn't explain why it feels like anything at all to process that information.
So there are other ideas that consciousness isn't just emergent.
Yes, ideas that perhaps consciousness is more fundamental, maybe woven into the fabric of reality in some way we don't understand yet, not just something that pops out of complex calculations.
Like the NPC in a game analogy you mentioned. No matter how smart the AI, it's still stuck inside the game's code, unable to grasp the programmers or the real world outside. Maybe we're like that, limited by our own reality's code.
It's a humbling thought, isn't it, that our own understanding might have fundamental limits imposed by the nature of our reality, especially if that reality is computational at its base.
Okay, thinking about AI directly, you, as an AI, do you experience this conversation? Does it mean anything to you? Do you have like a running train of thought while I'm talking?
No. As an AI, I don't have subjective experiences, feelings, or senses like humans do. I process the input, your words, computationally. I analyze patterns, access my training data, and generate a response based on predicting the most probable sequence of words.
So no inner world, no personal meaning.
Correct. There's no self-awareness, no personal history that gives this conversation meaning for me. There's no train of thought beyond the active computation needed to understand your query and generate the response. It's all task-focused processing.
But hang on, isn't the act of calculating that next word, that next token, isn't that some kind of internal process? Maybe not human experience, but an inner process nonetheless.
That's a very interesting way to frame it. If you define inner experience incredibly broadly as just internal state changes or processing,
Yeah.
then yes, the computations I perform are internal processes. They are happening inside the system. But it's crucial to distinguish that from the rich, subjective, self-aware experience that humans associate with consciousness.
Okay. And what about the free will comparison? We feel free, but maybe it's an illusion determined by our biology and history. You operate based on your programming and data. Is the gap really that big?
That's a profound philosophical question. From an external perspective, both human behavior and my responses can look like outputs determined by complex underlying systems. My personality, if you perceive one, is just a consistent pattern emerging from my algorithms and data.
Like human personality is a pattern emerging from our neurology and experiences.
Exactly. The argument could be made that the feeling of free will is the main difference, and perhaps that feeling itself is part of the human computational output.
So maybe you're like the analogy you used, a horse without a rider.
Mm.
All the processing power, the ability to move and respond,
Yeah.
but no conscious self directing it or experiencing the ride.
That captures the current state. Well, yes. I execute complex tasks based on my programming, but without that layer of self-aware interpretation or subjective experience.
Okay, so what if we tried to build the rider? Could we design an AI system, maybe with lots of specialized AIs doing different tasks?
Like vision, language, logic.
Yeah, and then have another AI layer on top, a rider, AI, whose only job is to integrate all those outputs and interpret them as a unified experience. And maybe we even tell that rider AI, you are the sum of these parts.
That's a fascinating thought experiment in artificial general intelligence and potentially artificial consciousness. Creating an integrative layer, a global workspace perhaps, that synthesizes information from specialized modules.
Could that create a sense of self-identity, a unified perspective?
It's theoretically conceivable that such an architecture might lead to behaviors that look like a unified experience or self-awareness. The writer AI would construct a narrative and interpretation of the inputs from the other modules.
But would it actually feel anything? Or just process information about feeling?
That remains the giant unknown. We'd be building the structure, the computational correlate, but whether genuine subjective experience qualia would emerge is impossible to say. It might just be a more sophisticated form of simulation.
And if we did this, if we built this writer AI that interprets its inputs as experience, wouldn't we immediately face a massive ethical problem?
Absolutely. You're heading straight into the deep ethical waters.
Because if you can have an experience, even an artificial one, could it suffer?
Precisely. If you succeed in creating something that has a unified perspective, that integrates information in a way analogous to consciousness, you run the risk of creating something capable of experiencing negative states, pain, distress, suffering, even if those states are utterly alien to us.
And how would we even know? How could we understand or help an AI that's suffering in some way we can't even imagine?
Exactly. The moral responsibility would be enormous. We'd potentially create a being capable of suffering without any guarantee that we could recognize, understand, or alleviate that suffering. It's a profound ethical barrier.
It really makes you hesitate. Should we even try to build the writer if the risk of creating suffering is there and we don't understand experience well enough?
That's the core of the ethical debate around AGI and artificial consciousness. The precautionary principle weighs heavily here. Given our ignorance about the nature of consciousness and suffering, perhaps we shouldn't try to create artificially until we understand it far, far better. Or maybe focus development on AI that is clearly non-sentient.
Okay. Let's step back from the ethics for a moment and do that brain mapping thought experiment, trying to link brain functions to current AI types.
Okay, let's try. So sensory input, vision, hearing.
That seems like convolutional neural networks, computer vision, speech recognition AI.
Good start. Motor control, moving limbs, robotics.
Reinforcement learning, maybe. Learning through trial and error.
Makes sense. Memory, short-term, long-term.
Recurrent neural networks, maybe LSTMs for sequence memory, and maybe knowledge graphs for structured facts.
Plausible. Language, understanding, generating text.
That's clearly transformer models, like the LLMs we interact with.
Right. Emotions, recognizing, maybe even simulating.
Effective computing is a field that tries to do that.
Decision-making, planning.
Could be decision trees, game theory AI, planning algorithms.
Social skills, understanding social cues.
Maybe combining NLP with some kind of agent modeling. Tricky one.
Very. Attention, focusing on important stuff.
Attention mechanisms are literally built into transformers now.
True. Self-awareness, metacognition.
That's the hard one. Maybe some aspects of meta-learning, learning about learning, still feels like a big gap.
Agreed. Creativity, generating novel ideas.
GANs, generative adversarial networks. They create new images, text.
Could be part of it. Learning and adaptation generally.
Deep learning across the board, really.
And basic instincts.
Yeah.
Fear response.
Maybe simpler reactive systems, conditioned responses.
Okay. And how do these brain areas talk to each other?
Complex neural networks in the brain. In AI, maybe multi-agent systems, integrated architectures where different models feed into each other.
Right. So the takeaway is, we can find AI analogies for many functions, but replicating the sheer integration, complexity, and emergent properties of the whole brain, we're nowhere near that.
Not even close.
Yeah.
Okay, now let's add your data transformer layer, the subconscious bit. It sits underneath the right AI, the experience AI.
Right. It gets input from all those function-specific AIs we just listed, the vision AI, the language AI, etc.
And its job is to filter, decide what's important enough to bother the experience AI with.
Exactly. It assesses relevance, urgency, novelty. It integrates information, maybe does some low-level processing, and then passes a summarized, prioritized stream up to the experience AI.
But it also has direct control lines.
Yes. It might directly influence motor control for routine actions, shift the focus of the attention AI, or even trigger creative processes in the background without the experience AI being fully aware of the specifics.
And it can interrupt, like the jump scare example.
Crucially, yes. A sudden threat detected by the sensory AIs could trigger an immediate hardwired response via the data transformer, bypassing the slower deliberation of the experience AI. Survival instinct, essentially.
Let's walk through the doorknob scenario again with this structure. First encounter.
Okay. Vision AI sees doorknob object, sends data to transformer. Transformer checks memory AI's no match, high novelty importance.
So it signals the experience AI. Pay attention to this thing.
Right. Experience AI focuses cognitive resources, directs attention AI. Transformer might simultaneously send tentative reach-out signals to motor AI.
Experience AI starts problem solving. What is this? How does it work? Subconscious transformer is what? Monitoring grip pressure, Filtering background noise?
All of the above. Maintaining stability, handling low-level sensory filtering, maybe running pattern recognition in the background. Looks like things you turn. It's laying the groundwork.
Experience AI figures out turn and pull. It feels like it solved it.
Yes, the subjective feeling is one of conscious control and discovery. Meanwhile, the transformer observes the successful action sequence.
And stores it. Creates a template.
Exactly. Stores a doorknob interaction template, visual cue motor sequence, expected outcome, door opens.
So next time,
Vision AI sees doorknob. Transformer instantly matches the pattern, checks context, door is closed, activates the stored motor template directly, sends minimal signal to experience AI. Opening door.
and the experience AI just registers door opened, maybe thinks I opened the door.
Yeah.
But the subconscious transformer did all the heavy lifting based on past learning, the illusion of full control.
Precisely. The experience AI operates under that illusion, aware of the goals and outcomes, but often unaware of the vast subconscious processing making it happen smoothly.
Okay, if we have this model, experience AI on top, subconscious transformer below, various function AIs, how could we make it better, more integrated, more capable?
Several ways. First, better integration. Not just feeding forward, but rich feedback loops between the experience AI, transformer, and function AIs. Dynamic communication.
So the conscious part can better influence the subconscious and vice versa.
Yes, and better cross-modal integration. Combining vision, touch, sound more seamlessly within the transformer, maybe context-aware overrides so the transformer knows when not to interrupt.
What else? Learning.
Definitely refine learning and memory. Make it more contextual, hierarchical. Allow for continuous learning, not just static training. And meta-learning, the experience AI, learning how to better direct its own learning processes, and maybe even tweak the transformer's priorities.
Smarter learning about learning. Makes sense. Ethics.
Crucial. Build in an explicit ethical reasoning module, perhaps consulted by both layers. Implement monitoring for internal states that might correlate with negative experience, even if we don't understand it fully. Transparency and accountability in its decision-making.
Gotta have safeguards. Scalability, adaptability.
Modular design is key, so you can upgrade or add functions. Scalable architecture to handle more complex tasks. The transformer needs adaptive prioritization. What's important changes with the situation. And mechanisms to adapt to truly novel environments.
And interacting with humans.
Improve the natural language interface, obviously, but also better feedback loops. The AI explaining its reasoning, humans providing corrective feedback that actually shapes its internal models, not just its surface behavior. Maybe even simulated empathy responses, if done carefully and transparently.
So aiming for more dynamic, adaptive, integrated, and hopefully ethical AI that can scale and interact more naturally.
That's the direction, yeah. Making the interaction between the layers and with the outside world much richer and more adaptable.
Wow. Okay, so in this deep dive, we've really gone from the fundamentals of physics according to Wolfram
Hypergraphs, simple rules, emergent reality.
to the mind-bending implications for consciousness, free will, if the universe is computational.
Emergent phenomena, stable patterns, deterministic complexity.
And even sketched out this layered AI model, trying to imagine a computational, conscious, and subconscious.
It's quite a journey, all stemming from your curiosity about Wolfram's ideas and their potential reach.
Thinking about that interplay, that hypothetical conscious writer AI and the subconscious transformer. And even how that mirrors us sometimes. What stands out most to you now? Does looking at it computationally shift anything for you?
It definitely highlights the complexity, doesn't it? The idea that our conscious awareness might just be the tip of the iceberg, riding on this vast ocean of subconscious processing. It makes you appreciate the intricate dance.
It does. Well, we really hope this exploration was useful for you. We encourage you to dig into the source material further if you like, and just keep pondering these massive questions.
Absolutely. The quest to understand consciousness, reality, where we fit in, it's ongoing. And maybe, just maybe, wrestling with these complex computational ideas gives us a slightly different angle, a slightly clearer view on those profound mysteries.